In the previous video, we discussed figuring out if a sample was an independent samples or if we had paired samples. You were given 2 examples and then asked to try the next 2 on your own. So now we're going to go through and explain those 2 examples, assuming you've already worked them yourself. So we want to see if gasoline with ethanol gets worse gas mileage. So we took 10 Hyundai Sonatas, 5 of them were randomly chosen to get regular gasoline, and 5 got gasoline with ethanol. Each were driven 250 miles under the same conditions, and we recorded their gas mileage in miles per gallon. So our quantitative variable that we're comparing here is the gas mileage, and our 2 groups that we're comparing are the regular gas and the gasoline with ethanol. So I'll go ahead and start by writing those 2 things. Those are our 2 groups that we're comparing. So what was your gut instinct? Were these going to be independent or were they going to be paired? Well, let's talk through it, because I will say quite often we might get this one incorrect, but I want to make sure we feel good with as to why. So first of all, we're sampling cars, so my picture is going to be a bad attempt here at drawing a car. So here's my beautiful car. So we have 10 Hyundai Sonatas. So just imagine for a moment that they're sitting in a line, and I'm just going to kind of number them in my head like 1 to 10 from left to right while I'm looking at them. And suppose that I happen to choose car number 6 as the first car that's going to get the regular gasoline. So then I go over here to my with ethanol group. Of course, I'm also sampling our car here. So we chose car number 6 to get the regular gasoline. So I have 9 cars remaining. Which one now has to get gas with ethanol because I chose car number 6 to get regular? Alright, it could technically be any of the 9 other cars. There is not a certain one that is matched with number 6. So because of that, these are actually going to be independent. Let's first write out why, and then I'll go back and explain why some people may have thought that it was paired. So here I have no known reason to match a car that got regular gas to a certain one that got gas with ethanol. And again, remember, we always assume independent until we know otherwise. Now, there's a multitude of reasons why some people will think this one is paired. So I'm going to go through a couple of examples as to why. First, if you were someone who knew these were independent, this will at least let you understand what others may have been thinking. But that way, if you were someone who thought it was paired, maybe I will address what made you think it was paired. One of the first reasons why students think it was paired is because each car was driven 250 miles under the same condition. So every car was doing the exact same thing. That made them feel like it was paired. Well, actually, that is really just to be consistent. That really has nothing to do with how the cars were sampled themselves. That's a great control, of course, for the experiment, but that isn't anything that's really telling me how the cars were chosen. Because here we really are focusing on the cars. So let's focus on those cars. Another person may believe that this should be a paired sample because all of the cars are the exact same model. I have 10 Hyundai Sonatas. I believe if I had a different model of car, that would make a big difference. Well, one, I will not disagree with you. The model of car is probably a very important factor when we're measuring gas mileage. However, all 10 cars are exactly the same. There isn't a one-to-one match going on. So my analogy for this example is to imagine, for example, my son gets a new 5-pack pair of Hanes socks that are all black. All 5 pairs are black, so I have 10 black socks. So when it comes to me doing laundry and I start putting the socks together, one thing that's nice at this point for me is I can put any 2 black socks together and I have what we would call a pair. But there's not 2 certain socks that have to go together. I could put any 2 I want. So those aren't really what I would call then a true pair if they could go with a multitude of other examples. So if you can put any 2 together that you want, it's not a pair. There would be a certain 2 that would have to go together. So for example, if you had 2 black socks and 2 white socks and 2 gray socks, and so I'd have to put those 2 matching colors together. Hopefully that explains most of the reasons that you might have thought that this one was paired. And it is also very helpful to think about it one vehicle at a time. Because another reason to possibly think it was paired is if I have 10 cars, 5 got regular gas, well then there's automatically the other 5 that got the with ethanol. That is correct, but again, is there a certain one in that regular gas group that gets specifically matched to one in the with ethanol group? So doing it one vehicle at a time can help you sort of see why there's not a pair going on here. All right, in the 4th example, we would like to see if Ally helps people lose more weight than a placebo. A placebo is just an inactive pill that doesn't have any active ingredients in it for people, make them think they're taking something. So we took a random sample of 50 people, and then we found a match that is similar to them on weight, gender, cholesterol, and apparently some other things as well. One of these people gets Ally, and then the other gets the placebo. They follow the same regimen for 8 weeks, and we record their weight loss. Well, our quantitative variable that we're trying to look at here is the amount of weight loss. And our 2 groups that we are comparing on weight loss are Ally and a placebo. So let's think through this sampling. So suppose that Sally is the name of one of the girls chosen, and she happens to get Ally. So now, because Sally got Ally, is there a certain person that has to get a placebo? Well, I know it's a woman as well, because we found someone that was the same gender here as well. Well, not just the same gender, right? They have to be similar to her on weight and cholesterol. So I couldn't just sample any woman I wanted here. I would have to sample someone who is technically Sally's match on all those other variables that we just discussed. So because I can't just sample anybody that I want there, or any woman even that I want there, this one's going to be a paired sample because for each person we found a match who is similar for comparison. So it does not have to be the same person or same item for us to actually have something that's paired. Here we found something that was very similar. Now, why would someone do that? Well, sometimes it's not possible for the same person to do 2 things. So for example, Sally can't take both Ally and a placebo. That would sort of defeat the purpose. And if they all took ally first and then a placebo, then I'd have to worry about that. So sometimes it's just easier of saying, okay, well, these two people are similar. I'll give one the medicine and one the placebo, and we'll see what differences exist between those people. And because they were matched on very similar characteristics that we're worried about being related to weight loss, then we're able to then measure the effect of how ally helps someone lose weight in comparison to doing nothing, which is what a placebo is doing. So as you can see, one of the first things that we're going to have to do inside this set of notes is make a decision if things are paired or independent. That's an extra step that we haven't had previously. So as we're reading through more and more examples, if you're not sure as to why things are independent or paired, please continue to ask me, because you will see that we will have some different methodology for paired versus independent samples, and it can result in actually different decisions being made because of it. And again, the reason why this is happening is because we expect measurements to be similar to each other when they're paired. So another example to end this video with that for you is, suppose we wanted to see how happy husbands and wives are in their marriage. So I decided to sample 20 husbands, ask them their happiness rating on a scale from 1 to 10. So let's suppose one of the husbands says, a 7. So now if I just sampled any woman out there, I don't really have any expectation of what her happiness rating should be. However, if I sampled this husband's wife, and he told me a 7, I'm going to hopefully expect that her value is probably going to be somewhat similar to that because they're in the same marriage. And so when I have this additional expectation of knowing that these values should be somewhat related, I want to use that to help me in my analysis as well. So you will see some differences going on as we start doing hypothesis tests and confidence intervals. We will actually start by looking at paired confidence intervals in the next video.